in determining whether or not it is a function, which is pretty easy depending on what's given to you. So they remind you here that a function is a relation where each x value corresponds to one y value. In other words, as we know, for it to be a function, x's can't repeat. So, if they give you the information about your function like they do on A and B, it's pretty easy to see if your x's repeat or not. But it also says another way you can visualize this is if you are given the picture like they give you on C and D. It says you just need to think about would it pass the vertical line test. All right, so let's take a look at these. For part A, do we have any x values that repeat? Yes. So is this a function? No. What about part B? Is that a function?
Yes.
Yes. All right, part C. Does it pass the vertical line test? Yes. So is it a function? What about part D? No, because it definitely does not pass the vertical line test, right? Okay, so if they give you the information this way, it's really easy to tell, right? The only other way they could ask you is if they just give you the equation and then you're supposed to figure out if it's a function. And it says to determine whether y is a function of x, we must solve the equation for y. Oops, meant to underline there. Okay, so all we are going to do is rearrange the equation so that it reads y equals whatever the other side is, okay? And the way we determine if it's a function or not is we're looking for two possibilities that would restrict it from being a function. It says the first one is if it can't be done. So if you cannot solve for y, it's not a function. Okay? The other thing would be if the solution is not unique. When I say not unique, I mean you're getting more than one answer or more than one solution. Okay? So if you can't do it, or if you get more than one solution, it's not a function. Otherwise, it is a function, okay? So let's take a look at a couple of examples. So in this first equation, if I'm trying to get y by itself, what would we move first?
The positive.
Huh?
The positive one to the other side.
Okay, so move it to the other side by adding. Okay, so I'd have square root of x plus 2y equals a positive 1. Okay? Then what should we move? Square root of x. How would I move it over? Subtract. Okay, so I'd have 2y equals negative square root of x plus 1. Then what should we do? Divide by 2. All right. So did we get y by itself? Yeah. And did I come up with more than one equation over there on the other side? So, if I solve for y, and I only get one answer, is it a function?
Yeah.
Yes. So my answer is yes, this is a function. Okay? Same thing for B. If I want to get y by itself, what do you guys think we should move first? Add the 5. Okay, so then I would have x minus 3y squared equals 5. Then what should we do? Subtract the x. Okay, so then I'd have negative 3y squared equals negative x plus 5. Then what? Divide by negative 3. Okay, so we're left with y squared equals negative x plus 5 over negative 3, right? And then how do we get rid of a square? Take the square root. Okay, now we talked about this in the last unit. If I take the square root of something, what do I have to consider? Right. So, when we solved this time, we get positive square root of negative x plus 5 over negative 3 and negative square root of negative x plus 5 over 3. So what do you guys think? Is this a function?
Yeah.
No, why not? Right, we had two answers. So the solution was not unique, is how they worded that there.
So y squared will never be.
Right, if you have to take the square root, you're always considering plus or minus. Now that's not true if it were a cube, right? because a cube, you know if it was positive or negative to begin with because it won't change, right? Okay, so those are the three different ways I'm going to ask you whether or not something is a function. Give you the points, give you a picture, or give you the equation. And now you can tell me all three ways whether or not it's a function. Okay, something else I wanted us to refresh ourselves on was this section where example number 3 is. It says to evaluate this function at the specified value of the independent variable and simplify. Okay, well, what's an independent variable, x or y? X. So this was just a fancy way of saying
I found this on the web.
Simplify whatever you get when they tell you what to plug in for x. So they tell you what to plug in, you simplify. So part A says f of x is equal to the square root of 2x plus 1 minus 3, and they say find f of 4. So what am I going to do? Plug in 4. So I'd have 2 times 4 plus 1 underneath that square root minus 3. And then it says just to simplify. So if I'm simplifying, what would I do first? Multiply. 2 times 4 would give us 8. And 8 plus 1 is 9. So I have square root of 9 minus 3. What's the square root of 9? 3. Okay. So I have 3 minus 3, which is 0. Now, we're not going to want to consider plus and minus here because in this particular instance, I know what I plugged in for x, right? It was a positive 4. So I'm not guessing if it was a positive or negative to begin with in this case because we know what we plugged in for x, okay? All right, for part B, g of t is equal to the absolute value of t plus 1 over t minus 3. Find g of negative 5. So what am I doing? Anywhere you see the letter t. So negative 5 plus 1 inside your absolute value over negative 5 minus 3. All right, so in the numerator, what are we going to get?
Negative 4.
Negative 4, but it is inside an absolute value. What's the absolute value of negative 4? 4. Okay, and what are we going to get in the denominator?
Negative 8.
Negative 8. And that is not inside of an absolute value, so it stays negative. Okay, and it did say we are simplifying all of our answers. So what would that simplify to? Right. Okay. For C, we have h of x is equal to x squared plus 1 when x is less than 0. And 3x when x is greater than or equal to 0. Okay, so they're saying this part is true if x is less than 0. This part is true if x is greater than or equal to 0. So depending on what we plug in for x, that's going to tell us which one to use. So if I'm looking for h of negative 4, am I going to be substituting that into x squared plus 1 or into 3x? X squared plus 1. Right, because negative 4 is less than 0. So I'm going to use this one. So I would have negative 4 squared plus 1, which is good. Okay? They also asked for h of 2. For h of 2, would I want to use that same one or would we use the 3x? The 3x, right? Because 2 is greater than or equal to 0. So for this one, we get 6. Okay? All right, for part D, they say find P of 3x. What does that mean to do?
Plug in 3x for x.
So anywhere we see x, I'm going to replace it with 3x. So I would have 3x squared minus 2 times 3x plus 1, right? Okay, so when we have that 3x squared, what does it mean to square something? Times it by itself. So this literally means 3x times 3x, right? Which would be,
9x squared.
okay, so we have 9x squared Okay, so now that I've taken care of the exponent, what do I do next?
Do you keep the square?
So 3x times 3x. 3 times 3 is 9. X times x is x squared, right? All right, so we took care of the exponent. What comes after the exponent in order of operations? Multiplication. So that's what we would do next, right? We're going to multiply. Negative 2 times 3x would be, right? And we still have that plus 1. Okay, so all that's left is addition and subtraction, but do we have anything we can add or subtract here? No. So this is as simplified as we can get it. We'd leave it as 9x squared minus 6x plus 1. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Brackets. Yeah. It's the same. It's the same thing, just different names. Brackets instead of parentheses, integers instead of the exponents.
You're so funny.
Yeah, when you have that integer to take care of at the top. Okay. All right, so we've got p of t plus 3. What does that one mean we should be doing? Very, very good. So I'll have t plus 3 squared minus 2 times t plus 3 plus 1. All right, so where do I start? The square, okay. And remember, t plus 3 squared literally means t plus 3 times t plus 3. So what is t plus 3 times t plus 3? Good. T squared plus 6t plus 9. Okay, make sure you multiply every piece. T times t times 3, 3 times t, and then 3 times 3. Okay? All right, now that I've taken care of the exponent, now I should multiply. So I'm going to have negative 2 times t, which would be, right, and negative 2 times 3, negative 6 plus 1, right? And now that I have taken care of the exponent and I've multiplied, now I can add and subtract, right? Okay, so what are we going to end up with here?
T squared plus 4t plus 8.
Plus what?
8.
So we got 9, negative 6, and 1. Plus 4. Yeah. Okay. All right. Flip it over onto the back. And they have a few reminders for us about our domain and range. Okay, so it says here that we can write the domain and range in a variety of ways. So in the past, I've kind of just let you guys write it whichever way you prefer. But from here going forward, sometimes they're going to be specific about the way they want you writing it. So I want to go over all the different notations just in case it's one you haven't used in a while. So first is probably the most commonly used, which is the interval notation. An interval notation is a way that you would write a set of points or a portion of the graph using commas, brackets, and parentheses. So in the past, you may have written this as something like -3 to 4, right? Okay, the second is inequality notation, which is basically the same as set notation, but without that extra set of brackets, where you write it with just inequalities. So this would be where if you had that same one as up above and you were writing the domain, you would say -3 is less than or equal to x is less than 4. Okay. All right, and then the third one says set notation describes the properties an element must have to be included in a set. So it looks a lot like the inequality way of writing things, but it has these brackets here, and it'll say x such that, the line there is such that, and then you would write this part. The -3 is less than or equal to x is less than 4.
Wait, why would you write it in the last one?
Why?
If it's just like.
If it's the same thing?
It's the same thing.
This is the proper way of writing this one.
Okay.
But a lot of times, just like I don't always make you guys include the unions because it's not absolutely necessary, it's the same kind of idea.
Okay.
So typically, if I ask somebody to write it in set notation, this is the proper way of writing it, but it means the same thing as this. Okay. So now that we've gone over the different ways to write it, it says find the domain of the following functions. This is the set of all x values that correspond to a point on the graph. You must include any x values that do not correspond to a point on the graph, and you may use a graphing calculator. So I did teach you guys about some restrictions for things like square roots or fractions, but if you don't remember them, then, like it says, you can just put the function in your graphing calculator and see what the picture looks like. But I want to give you guys a second to fill in the domain and range for these functions. Or sorry, not domain and range, just domain. All you have to give me is domain. So if you don't know what it looks like and that's keeping you from giving it, just put it in your calculator and get yourself a picture and then list the domain for me. So I'm going to give you guys just a minute to do that. Again, if you're not sure what that picture looks like, just put it in your graphing calculator. How do you put one in? Yeah. So you just press the button that says math. This screen pops up. Yeah. So just hit the button that says your functions. Yeah.
How do we say
So
domain, that's left and right, right? Is this thing ever going to stop going this way? Is it ever going to stop going that way? So it's everything except this area right here. So what number?
I deleted Instagram for a whole week.
So make sure you write it in either the set or from negative infinity to 4 and stop. What?
That does not say Santa Claus.
That's great. We use unions too.
If you don't have it.
Oh my god!
Wait, I think this is.
What?
So these are your notes. You can write it however you want. But I do want us to make make sure we know how to write it all three ways. So if we were given this as a question on a quiz and they said write it in set notation or interval notation, then you would be able to write it.
Oh, I didn't say that
The
was
second one's progressive, so like it comes off right there, so I go to the table, so it would be negative infinity or
You didn't say anything. Like, let me. Say who's winning.
Do you remember Ashley? Alright guys. We're gonna all filled in. Wait. Oh.
Bro, I mean, I wasn't home all, but it's funny.
He was winning.
What's yesterday? I don't
Because the first one did you get all the numbers?
I went.
It's all real fast. Right, feel like it.
No, honestly, the second one, there's a
Yeah, no, that's.
Yeah.
What?
I was just.
So you know that, but you don't know who's on there. Do you smile?
Wait, I didn't, you said that, is that my name?
Oh, that's,
I thought you said it was that.
either start or then I don't.
Because she thinks they're rude.
Oh,
Yeah, sure, that way.
And we should do that.
Negative infinity to 4.
Bro, what did I do?
Alright, let's go. Wait, Ashley, the last one, all the numbers.
Does it look like that?
Something what you're supposed to look like. Or did we only?
Just like, no, because you're so good.
You're right. Wait.
You're not, you don't have to.
So you just say negative and need a positive or something? Wait, how do we write that?
Yeah, so
Okay, looks like most of you guys have majority filled in, so let's talk about what we come up with. For part A, whenever you graphed that in your calculator, if you weren't familiar with what a cubic or a quartic function looks like, what ended up happening? What did it look like?
It just looked like, it just went up and down.
Yeah. But this end pointed up, right? And then we had some stuff happening. And then did it go eventually back up or back down?
It went back up.
Okay. All right. So for my domain, I'm only concerned about left and right motion, right? Well, since it went continuously both ways, then what would we say our domain is?
All real.
All reals. So we can either write that in interval notation as negative infinity to infinity, right? Or in inequality as negative infinity is less than x is less than infinity, or in set as x such that x is between negative infinity, or you could also do the set of all real numbers. Okay? All right. Now for B, you may have graphed it in your calculator, but I also want to remind you guys of that rule that I taught you at the beginning of the year as far as restrictions go. What do we know we're not allowed to have in the bottom of a fraction? A 0, right? I can't have 0 in the bottom of a fraction because it would be undefined, right? So what number would I not want x to be because it would give me 0 in the bottom? 4. So I don't want x to be 4. So I would say that it goes from negative infinity to 4. and then from 4 to infinity, right? Or from negative infinity is less than x is less than 4. 4 is less than x is less than infinity, right? Or set, same thing as the second one there. Okay? All right. For C, again, you may not have remembered what this rule was, so you might have put it in your calculator, but the rule that I reminded us of was that we can't take the square root of what? A negative number. So I would just want to make sure whatever I put in for T doesn't give me a negative, right? What's the smallest number that I can plug in for T and not get a negative? 5, right? As soon as I plug in even 4.9, all of a sudden I would get a negative. So we would say that x has to be greater than or equal to 5, or from, that would be a bracket, 5 to infinity, right? Okay. All right, now this last one, we've got a cubed root. This one, again, we may not be super familiar with what the graph looks like. So you may have put this one in your calculator. Can anybody tell me what this one kind of looked like?
It just looked like, it looked like a x cubed but opposite.
On its side, right? Like an inverse. Okay, so x cubed normally would look something like this. So this was on its side, so it looked something like this,
Yep.
sort of. Okay. All right, well, is that thing ever going to stop going to the left or right? And there's no place where it's discontinuous, right? So we would just say it is also from negative infinity to positive infinity, or negative infinity is less than x is less than infinity. Or x is the set of all reals. Okay? All right.